Hi, today I'm going to talk about the variety of applications of acids and bases. This presentation consists of two parts. In the first part, I will go through the definition of acids and bases, pH scale, and neutralization reaction. The applications of acids and bases will be taught on the part 2, which including the usage of acids and bases in agricultural, industrial, and medical field. More information and details about this topic can be found in your textbook, chapter 10, called Acids and Bases. Acids and bases are chemical compounds that have distinctive properties in water solution. The sour taste of a lemon, lime, or grapefruit, for example, is caused by citric acid. The slippery feel of ammonia, a common base, is characteristic of all bases. One of the most interesting properties of acids and bases is the way they react with indicators. An indicator is a material that changes color in the presence of an acid or base. For instance, the hydrangea flower can be either pink or blue depending on the amount of acid or base present in the soil in which it is planted. Acids and bases have been known since prehistory times. Vinegar, for example, is a water solution of acetic acid that has been used for centuries. The first modern definition of acids and bases was suggested by Swedish chemist Svante Arrhenius. Arrhenius proposed that acids we define as chemicals that produce positively charged hydrogen ions in solution. By comparison, he suggested that bases are compounds that produce negatively charged hydroxide ions in water. One of the most important characteristics of acids and bases is their strength. The strength of an acid or base depends on the number of hydrogen ions or hydroxide ions produced in water solution. Since all acids and bases do not ionize to the same extent, it leads to the statement that acids and bases are not all of equal strength in producing hydrogen ions and hydroxide ions in solution. The strength of an acid or base can be determined by using the pH scales. The term pH stands for potential of hydrogen, and the pH scale is a meaning of determining the acidity or alkalinity of a substance. There are theoretically no limits to the range of the pH scale, but figures for acidity and alkalinity are usually given with numerical values between 0 and 14. A rating of 0 on the pH scale indicates a substance that is virtually pure acid, while a 14 rating represents a nearly pure base. A rating of 7 indicates a neutral substance. The pH value can be calculated by the formula pH equals to the negative log of the molar concentration of hydrogen ions in the solution. Acids and bases react with each other in a reaction called neutralization. As you can see from the equations above, in a neutralization reaction, the hydrogen ion from an acid and the hydroxide ion from a base react to form a molecule of water. The neutralization reaction of an acid with a base will always produce water and salt. Some common examples are shown below. Neutralization has many practical applications. For example, agricultural land is often too acidic or too basic to grow certain crops. Farmers can add either a weak acid or a weak base to produce the level of acidity or basicity in which various plants grow best. Reclamation of land once used for mining also involves neutralization reactions. Such land is often too acidic for plants to grow. Treating the land with calcium oxide neutralizes acids remaining in the soil and restores its fertility. Neutralization is also used to deal with the environmental problems. Gases produced in factories, power generating plants, and other industrial facilities are usually acidic. When they escape into the air, they react with water to form acid rain. Scrubbers that contain bases can be attached to the inside of smoke stacks in such plants to neutralize acids in escaping gases. Acids and bases can be found everywhere in the world around us. Lactic acid occurs in our sour milk, citric acid in citrus fruits, oxalic acid in rhubarb, malic acid in apples, and tartaric acid in wine. Baking soda, antacid, and lye all contain bases. The table listed some common acids and bases which you can find at home. Also, acids and bases are very important in our body function. Our stomachs produce gastric acids to aid in digestion. This acid is mainly composed of hydrochloric acid that is secreted by the cells of the stomach lining called parietal cells. Excessive secretion of this acid is common and can lead to many stomach problems. These disorders are treated by antacids, which reduce the amount of acid in the stomach by various means. Most antacids contain weak bases, and they neutralize the stomach acids by reacting with them chemically. These antacids are best taken for occasional stomach problems, and they act very rapidly to provide relief. Some of the most common bases that are used as antacid are magnesium hydroxide, aluminum hydroxide, sodium bicarbonate, and calcium bicarbonate. These chemicals are used because they are weak bases. Strong bases would lead to the risk of damaging the stomach if too much were taken. Bases neutralize acids by reacting with them to produce the salts and water. The chemical reaction of a weak base with stomach acid can be written in the general form: weak base plus hydrochloric acid produce salts and water. A specific example of this chemical reaction is magnesium hydroxide plus hydrochloric acid produce magnesium chloride and water. Acids and bases are also used widely in industry. 3 of the top 10 chemicals produced in Canada each year are acids or bases. In 2006, 400 million kilograms of sulfuric acid were manufactured in Canada, making it the #1 chemical in the chemical industry. In addition, 112 million kilograms of sodium hydroxide and 110 million kilograms of sulfuric acid were produced. The most important single use of acids and bases is in the manufacturing of other chemicals, fertilizers, synthetic fabrics, pigments, petroleum, iron and steel, explosives, dyes, plastics, pesticides, soaps and detergents, paper film, and many other chemicals are produced from acids and bases. They are also used for various other purposes, including cleaning surface, refining oil and sugar, electroplating metals, and treating food products.